Hello students, good morning and welcome back to KCS online platform, and we are in bridge course. Okay, so today again I am going to discuss one more very important concept which we often use in our day-to-day life, that is what energy. I am standing here because I am having some energy. You are watching half an hour of video means you are having some energy. So what kind of energies or what kind of energy you are getting when you are moving, or when you are sitting, or when you are at the first floor, when you are at the second floor. Those all things we will discuss today. But before that, in the last video lecture, what we have discussed only about the force. So there is one more thing, that is what pressure. We will spend 2-3 minutes on that one. Then we will go back to the energy. Okay. So what is that? That is the pressure. Okay. So what exactly pressure is? What exactly pressure is? So normally what we can say, the intensity of force means how much force you are applying on a given area. That is what we call it as the pressure. So normally what we can say, it is the intensity of force, or pressure we can always write it as force divided by area. That means how much force you are applying on an area means, or force per unit area. So what you can say, that is force divided by area. Okay. So force divided by area means what? It is nothing but force per unit area. Force per unit area. That you can call it as what? Pressure. So unit, you already know what is the unit. Unit is force. Force is Newton, and this is what? Newton per meter square, or generally used unit for the pressure is what? Generally we can use the Pascal also. You must have gone through this one in your 9th or 8th class, what exactly pressure is. Okay. So what it means? Suppose there is a fat person, very fat person. Suppose there is a lean person. If he apply the force on this one, will he get any effect, or will he get any hurt from this person? No, because area is large, applied force is small. But if this person applies some force on this small this lean person, what will happen? He will get hurt because area is small. This is an example. But where we can see this one, suppose if you look at the formula, your pressure is directly proportional to what? Force. That means if force increases, pressure will also increases. If force decreases, pressure will also decrease. Similarly, so pressure is inversely proportional to area. That means if area increases, pressure decreases. If area increases, pressure decreases. So if you want to get the more pressure, what is required? Required is more force and less area. Getting the point? If you want more pressure, what required is force required is more and area required is less. Then what will happen? You will get the maximum pressure. For example, suppose if you have seen your needles, what is the shape of needle? Shape of needle is like this. Here they have given the very point one. If somebody slap you with this much of area, what will happen? You will not hurt much. But when somebody pinch with the pin, it's having very small area, but what will happen? You will hurt more. That means this is what giving the more pressure. This is what giving the more pressure. That is why what you will get hurt. If suppose instead of this one, if you have the needle like this, you apply force F on this, force F on this, which will penetrate. This will penetrate into the some material. This never penetrates. Okay, you must have experienced the needle with blunt edges won't penetrate into the walls or something. Okay. Similarly, suppose you are having the apple. Okay. So to cut that apple, what you will use? You will use your knife. Okay. So if you are seeing your knife edges, it is very small. So if it is very small, what will happen? Area will become small. And applied force is say F. If area is small, what will happen? If area is small, if less area is there, pressure will be more. That is why if you take an apple, you can use your whole energy and try to cut it. It won't possible. But a small the small knife can cut that apple without applying more force. You will just apply little force, then also it will cut. What is the reason? Reason is knife is something God gifted. It is not like that. What is it is you are applying the force on small area. Okay, that is what the reason how we can cut the fruits or something. Okay, so like that you can see many examples. Suppose there is a balloon. Okay, so you apply the force on both sides on the balloon. Okay, so if you apply force from both sides on balloon, so what will happen? Will balloon will blast? No, balloon will not get anything. Okay, instead of that one, if you take a small pin and just apply little force, so what will happen? It will get blast. Okay, why? Because area is very small and you are applying the force. When force applied on the small area, obviously what will happen? You will get the more pressure. Okay, or similarly, suppose if you are traveling on the bike. Okay, suppose if you are traveling on the bike, so suddenly there is a rain started coming. Okay, a small drop of rain, when it touches your face, it will hurt you more. Why? The area of contact is very less on your surface. Force to same. If somebody pour a bucket of water on you, you will not get hurt. But these small droplets of air, so what will happen? They will hurt you more because area is small. Because of small area, what will happen? They will apply the more pressure. Okay. So these are the common examples which we have seen our day-to-day life where we get the more forces. Okay. So force is what? Force is directly proportional to, pressure is directly proportional to force and inversely proportional to area. Now we'll go with the energy. What exactly energy is? Okay. So my first question is what? My first question is when do you say there is energy? There is energy. When do you say there is energy? Suppose if I say I have a lot of energy, how I have to prove it? I am having energy. Or if somebody is having energy, how we can prove it? Okay? Or some machine is having some energy, how we can? That machine has to prove. So what is our question? When do you say there is energy? Very simple. If I want to show that I am having the lot of energy, what to do? I have to do some work. When I do work, then only what I can say I am having energy. Then only you can believe, yes, this person is having energy. If a person cannot do work only, then even though he say I am having energy, there is no meaning. So when do you say there is energy? When there is work. And there is work. Okay. This is very important. When we say there is energy, when there is work. If there is no work, you cannot say there is energy. That means what? Energy is nothing but what? Energy is nothing but ability to do work. Getting the point? Ability to do the work. The person having more energy will do more work. The person having less energy will do less work. That means what? Energy is nothing but ability to do the work. Then what is work? On which work is depends. If you are very much clear with work, then you will be clear with energy. Okay. Then when do you say there is a work? Suppose there is an object, you have a lot of energy and you are applying the force on this one. You are applying the force on this one. Okay. So it was at this position A. Okay. So somebody see you applying the force. Somebody see you applying the force and he will go and he will come after 5 minutes. He will come after 5 minutes. So again he will see you. Again you are applying force, but object is there at A only. Object is still there at A only. That means object is there at the same position. Object is there at same position. Then that person what he will say? He will say you are not doing anything, man. You are not working only. So if same question means what? There is no displacement. There is no displacement. Getting the point? So this person, you are doing the work. You are doing the work. There is no doubt. You are applying the force. But for this person, when he come after 5 minutes, then also if body is at same position, obviously he will think that you are not doing anything. You are sitting here. Or suppose there is a body and you are applying a little force. Okay, so one person is seen you are doing some work and it is at point A. So he go and come back after 5 minutes. But when he come back after 5 minutes, your body was not at A, it will come to at point B. Say it is displaced, say by some distance. Yes. Now no need to tell that you are doing work. When the person comes and see, he will himself say, yeah, you are doing some work. Why? Because there is a change in position. Change in position. That means what? There is a displacement. There is a displacement. Okay. So what we can understand from this is, if somebody want to say there is a work, what we have to show? There should be some displacement. If I move the object, then only you can agree that I am doing work. If I do not move this object, then you cannot agree with that if I say I am doing the work. Getting the point? That means to say there is a work, what is required? There should be displacement. There should be displacement. No displacement means no work. And one more thing is, to displace the body, what is required? What required is force. Okay, that means there should be force. So for work to be work is said to be done, what are they required? One is force, another is displacement. Okay, so that is why what we write for the formula of work is always equals to force into displacement. Force into displacement. Okay, that is work equals to force into displacement. That is what you can say Newton meter. Okay, so don't worry about Newtons and other things. You will study in the next chapter. Okay, so that is what W equals to F into S. Okay. So now work depends on what? Work depends on force and displacement. Suppose force is 0. Suppose force is 0. If you substitute 0 here, work is going to be what? Work is also going to be 0. Okay. So if work is 0, you will say there is no energy. Or if displacement is 0, what again? Work is 0. That means there is no work. Okay. So if you want, suppose if you want to do the work, what is required? Required is displacement. Okay. So if you want displacement, what you have to do? You have to apply the force. So that is what? Force. Okay. To apply the force, what is required? What is required is what? Energy. What is required is energy. That means if you have energy, you will apply the force. If you apply the force, displacement will take place. If displacement will take place, then somebody can say, yes, there is a work. That means your work is nothing but energy. So work done is nothing but what? Your energy. Are you getting? If you have energy, you will apply the force. If you apply force, displacement. If there is a displacement, work. That means if you have energy, then only work. So amount of work done is only what we can say. We can say that it is the energy. I hope you got what exactly energy is. So now we go with the main types of energy. In a sense, how we can divide energies. Okay, I'm not going to go with all different types of energies, just general. So you must have studied already. One is kinetic energy. One is kinetic energy. Another is potential energy. Another is potential energy. Okay. So kinetic energy and potential energy. Okay. So we will go with the kinetic energy. What exactly kinetic energy is? Kinetic energy. Okay. So kinetic energy. See, kinetic means what? We have already discussed before. Kinetic means what? It is in motion. Kinetic what means it is in motion. So what you can say, when there is a when body is moving, suppose when you apply the force, so what will happen? It will move. So it may comes to here. While moving it will get some energy. While moving it will get some energy. So that energy, what they will call it as? They will call it as kinetic energy. Have you observed this anywhere? When the person is moving, it will get some energy. For example, there is a bowler. Okay, so he will run from some distance. Then what will happen? Then he will throw the ball. Okay. If you stand here only and throw the ball, what will happen? Will it go with a high speed? No, because amount of work done by you is what less. But when you come from some distance, when you run from some distance, that is why always the speed bowlers will come from what some distances. Some people used to come from boundary line also. So what will happen when you run from here to here? When they run from some distance, they will get some energy. That means due to their motion, they will get some energy, and that energy is called as what? Kinetic energy. That means energy due to its or body's motion, or simply you can write energy acquired due to motion. Energy due to motion is called as what? Is called as the kinetic energy. For example, a bullet is coming. Okay, if a bullet is coming with a high speed, so what will happen? Then what will happen? It will penetrate and or it will blast something. It will destroy something. That means it is doing some work. From here, that to do that work, what is required? Energy is required. From here, that energy is coming because of its motion. Because of its motion, that energy is coming. Because it is doing some work here. It is doing some work means what? Energy is required. That energy is coming because of its motion. It is moving for a long distance. Okay. So that is also what the kinetic energy. Okay. Now, then how you can calculate the kinetic energy? Say, suppose if I take instead of if I throw a small ball, okay, a small ball will what hurt you less. Instead of that one, if suppose if a person is running from some distance, and if he throw a cricket ball, it will go with a high speed. Okay. Instead of that cricket ball, if I use something of bigger size, what will happen? So will it able to throw it with a large with a high velocity? It is not possible. That means the energy acquired by the bodies will depends on what? Will depends on the masses. Second thing, when I throw a cricket ball, it will hurt you less because speed is less. Instead of that one, if I throw if I use the gun and if I throw what bullet, so this will hurt you what? It will hurt you more. That means it got more energy. So energy depends why it is moving with a high speed. So energy depends on what? Velocity also. That is why kinetic energy we write it as half mv square. Kinetic energy we write it as half mv square. Okay. Kinetic energy depends on mass also. It depends on velocity also. Okay. So this is what the equation for kinetic energy. So next is what? Potential energy. What exactly potential energy is? Potential energy. So what is the potential energy? So suppose this is a surface. If there is a body, okay, will it move? It will not move. Why it will not move? It's no moment. Why no moment? no work, no work. Why no work? No energy. Getting? Why no work? No energy. Okay. So now, if somebody comes and if we lift the body to here, if somebody comes and lifts the body to at some height, to lift from here to here, he has to do some work. To lift the body from here to here for a height h, he has to do some work. Why he has to do work? Because there is a gravitational force. There is a gravitational force. He has to do work against the gravitational force. Okay, so he will do some work against the gravitational force to lift it here. Okay, so that work will convert into what? That work will convert into energy. Okay, so when body was here, no energy. When body comes here, there is some energy. So because of its position, what you are getting? You are getting some energy. Because of its position, you are getting some energy. Okay, so that energy we call it as potential energy. That energy we call it as the potential energy. So why you are getting energy here? You are getting energy due to its position. Okay, energy due to its position. So due to its position, we call it as the potential energy. Due to its motion, we call it as the kinetic energy. Okay, so many examples you can see here. Okay, so when something is at this much height and another body is at this much height. Okay, if a person jump from here, okay, so less hurt. When he jump from here, more hurt. Okay, so why it is? Because here potential energy and here potential energy may be different. So when a person jump from here he is having what kind potential energy. So when he jump here, that potential energy will convert into what? Kinetic energy. And when he come to a surface, what will happen? Suddenly energy should become zero. Then where this energy should go? This energy should do some work. When it do some work, that will destroy your body. Okay, you will get hurt because of what? Because of energy. Because work done by the energy. That is why. So now how it vary for this person and this person. You can generally say if you jump from the first floor, lesser. If you jump from the second floor, there is a more. That means energy depends on what? Your potential energy depends on what? It depends on h, height, how much height is there. So what is the force acting? Gravitational force, that is acceleration we have to take z, and it depends on mass also. Okay, so that is why potential energy formula is what? Potential energy formula is mgh. Okay, so these all things you will study in your work energy power chapter and in your first PUC only. So still there, just remember what exactly kinetic energy, what exactly potential energy, and what is the total energy. Okay.